Hello. It is a weird time to be streaming. Hold on. Got music way too loud in my ears. Gonna make sure that the levels are right. Barnacle, hello. How's it going? Oh gosh, what have I just done? Ugh. Sounds alright. Maybe maybe put the music up just a little bit. But yeah, hello. Welcome back. We're gonna do some URP today. I've been having a lot of fun. I've been having a lot of fun messing around with Universal Render Pipeline. I've moved about in the room again because we've actually got like the majority of the flooring down in here now. Still need to paint, and there was also, we ran out of floorboards, so I had to order some more. But they are on the way, and won't come until tomorrow. So shuffled around again, still in the living room, but everything's good. Everything is going well. Yeah, and we're gonna have some fun today doing some Universal Render Pipeline custom post-processing effects. But, you know, before I do that, I'll do the obligatory for, you know, recording, and anybody who's watching who has not been around before or isn't already in there, we have a Discord server. Updates like what I've been working on outside of these streams go in there. I've been a little bit quiet, but there's like I've got loads more time to do stuff at the moment, which I'll make a video about that at the end of the week, so keep your eyes peeled for that. But let's just dive straight into it, shall we? So like we say, custom effects with Universal Render Pipeline. We're working on a new game at the moment, off the back of Thailand, something new to release. It's very cool. I'm very excited for the project, and one of the cool things that we've got about it, without going into too much detail because we're still like ironing out the details, one of the cool things about it is thematically it's all based around like old style DOS computers, and that means I get to do a whole load of fun stuff with post-processing effects, and I'm gonna use it as an opportunity to kind of do a little bit of a tutorial around Universal Render Pipeline and custom render passes and everything, because it's actually a lot more straightforward than it seems, and a lot of that is down to just how bad the documentation is at the moment. It's pretty jank, not gonna lie, but like all of this stuff that's happening on screen right now is all custom render pipeline stuff. Like if we look in Unity itself, hopefully you can see, because I've got a new monitor which is very large, so the resolution might be a bit squiffy, but hopefully you can see on here all that's in scene at the moment is just some UI that's got, you know, it's completely white, all just, yeah, normal text, normal font, and then we're pushing it through a bunch of, again, custom post-processing, which is adding things like the curve, scan lines, the bloom. I want to add in some stuff like noise, maybe a bit of like old style static distortion as well, and a lot of these features are kind of based around an asset that was used for Inscription, funnily enough. It's called old what's it called, like old TV effects or old TV filter or something like that, and it's a cool asset. I left a review for it actually, because the stuff that it's made up of and the things that you can do with it are awesome, but it's not updated to work past Unity 2020, and you know, we're on Unity 2022. Unity 2023 is like around the corner. Unity 6 is somewhat around the corner, and URP is like way above the version that supports it. Like I think I'm using URP version 14 in this visual prototype, but yeah, there's just it doesn't even support like URP 13, I don't think, and the latest version of URP is like 16 or 17 coming up soon, I think. So yeah, it's just like you can't use the asset, and trying to update it to work with the latest URP version is a real pain. So I'm just making everything from scratch because it's way more straightforward than you would think it is. Wanted to say it reminded you of Inscription. Nice, that's cool, because I'm a, you know me, big Inscription fan, and yeah, the kind of effects that exist on the old TV stuff are really cool. So let me give you a bit of a show around of what we've got already, or talk about some of the structure for how this works. So the way that Unity's scriptable render pipeline works is exactly that. It gives you a way of writing scripts in C# that define the process for how your game is going to render. So there's a whole load of default stuff in that within the universal render pipeline. That's like it gives you the basic mobile / low performance console friendly rendering features, but you can also add in custom render features, which are down here in the bottom right, maybe not visible too well on screen because again resolution is so damn high. But what we're doing here is basically defining our own custom render feature called CRT render pass feature, and that's what then handles layering those passes over top. So 3 components that we've got a custom post-process volume component, which is over here, and lets us add things like, you know, the scan line effect that I've made, color remapping, so we can go in here and like change the color that we want to render this stuff in at runtime. Those are the only 2 that we've got at the moment actually, but we're going to add a couple of more based on the thing. So that's the first part, custom volumes. Second part, like I say, is that custom post-process pass, or the custom render feature, which is our CRT render pass feature. And then there's an extra bit on top of that, which is our actual render passes rather than the render features, and these are what actually handle doing the application of our effects onto the screen. So the way it works is you basically it makes it so much easier now the way that this works, because you can use shader graph as well to define these custom effects. So like in my case, I've got 2 shaders, one of which is for color remapping, that I've made in shader graph here. What am I doing? There we go. So if I just zoom into this, it's a really quite simple shader graph. All it's doing is taking in a color that we want to remap to and an intensity that we want to apply it by, and then we're just lerping between white and that color based on the intensity, rather than like doing any multiplication, because if intensity is 0, I just want the color to be what it was before and then mix in like a little bit of that color over time. So it takes then the screen image, which refers to the blit source, which blitting is effectively how you remap a texture onto an existing texture in the screen, kinda. That's very, very much a bad description, but roll with me. So we're effectively taking what the screen looks like beforehand and then multiplying it by this remap color, and then yeah, just outputting that to the base color of the shader. And then for the scanline texture, we're doing kind of a similar thing. I've got this pattern of kind of red, green, blue pixels. So like if I zoom in on the screen here, you can actually see where we're actually pushing these colors through these pixels. And the way that it's doing that is by, like I say, again, we're taking our screen and splitting it into red, green, and blue channels. And then we're taking our scanline texture that I described before, doing the same thing, splitting it up into red, green, and blue after, you know, scaling it how we want to based on the number of lines we want. And we're then multiplying each of the red, green, and blue together, combining that into an RGB thing, saturating it so that it doesn't go above a value of 1, and then pushing it out through the base color of the texture. So in our render pass feature, or our render pass where we're doing the scan line, that's literally taking an instance of this scanline material, and we're then setting all of the values for what texture we want to use, how much effect we want to have, and how many lines there are going to be, setting all of those in the material based on the settings in our post-processing volume. And then, like I said before, we're doing a blit of that, of the screen texture onto itself through that material, using the first pass, which there's only one pass in the shader because I think URP by default doesn't support multiple passes, so any shader graph shaders are just a single pass thing, but it basically is like as simple as doing things in that kind of order rather than you know, having to do anything too complicated. So we're effectively gonna probably refactor this a little bit just to do a lot of this like boilerplate stuff in a base level, and then we can create a bunch of implementations for that class. So I'm going to start doing that now actually, but first let me let my cat in because he's wandering around. Leave the window and let him come in a second. I need to make sure my camera doesn't go out of focus as well, don't I? Because it's on manual focus, so if I move it's gonna go out. I think you can see a dog, so he's just he's chilling on the windowsill. Anyway, right, let's go ahead and start this off. So public class, and I'm going to call this CRT render pass. It's going to implement our scriptable render pass, and let's go ahead and have it do the execute gubbins. So what I would like to do is basically take this section here for what's happening inside of the profiling scope, which is just a way to let me look in the frame debugger and see, you know, what each of these different stages are doing, and it does that on a per blit basis, I'm pretty sure. So I want to effectively take this bit, stick it in a function that is abstract, or stick it in some abstract function, and then have everything else happen as a base because it's all default. And I also probably want to have a type for the post-process volume that we're going to reference to. So let's go ahead and make this generic and say where T implements or inherits from volume component. And then in execute, let's go ahead and start setting some stuff up. So we're going to have a constructor, public CRT render pass. Oh, can't type. And this is going to take a material, which will be our post-process material. And we'll have a reference to that as well. So private material, post-process material. Oh, I don't know if the cat came in or if he's just left the windowsill, but he's not there anymore. He is a weird cat, that one. Right, cool, so we've got that in, basically the same as we've done here. We're going to set the render pass event to be before post-processing. Before rendering post-processing, fantastic. So that's the constructor side of things handled. We are going to have a private RT handle, which is a render texture handle. This is going to be the reference to our the screen color render texture, effectively, because you get two render textures off the top of my head, which are the color texture and the depth texture. We don't care about the depth texture, we're not doing anything funky there, we're just going to use the color texture. So we'll call this color texture handle, like so. Do I need anything else? maybe I want the profile sampler. You know what? Yeah, let's do that. So private read only. We can probably make this material read only as well, because we're not going to change it in here. We're just going to, or what, we're not going to write to that variable. We're just going to change values that are in there. So private read only profiling sampler, which is going to be our profiling sampler. Come on, profiling sampler. And we'll instantiate that here as well. So we'll say, let's also pass in a string for our profile sampler name. I'll say profiling sampler equals new, passing in the profiling sampler name. Fantastic. And then we need this set target method. So let's do that. Public void set color target. And this is going to take an RT handle, color texture handle. Whoop. Color texture handle, blah, blah, blah. On type, there we go. Color texture handle equals color texture handle. And cool. I'm gonna copy paste this now because we're gonna do basically everything in here. Like I said before, difference being we're now gonna have a protected abstract void apply post process effect, which is going to take a reference to our command buffer CMD, and I think that's probably it, because we've got the we've got all of these as members anyway. Let's just make sure these are protected. Let's also make sure we make this class abstract as well, because we don't want to be able to make a direct instance of it. Cool. So this is going to be of type T. We're going to change this to be our Ooh. No, yeah, that's fine. That's fine. We can have a protected T scanline effect. This is going to be our post process effect, and then we can use this in all of our places basically. Let's make sure T also implements I post process component. Syntax, comma, there we go. We want it to implement both of those things. Cool. And then here, rather than doing all of this stuff, we are going to just call apply post process effect, passing in the command buffer as our command buffer. Sweet. That should theoretically do it. Yeah, that should theoretically do it. So then rather than having these be scriptable render passes straight up, we're going to have them be CRT render passes of type scan line effect. And that means I can copy this, delete everything that's in here, and paste it into our apply post process effect. This is no longer called color handle, it's called color texture handle. So we're going to paste that there. Our material is going to be post process material, and our effect is going to be post process effect. Bang, 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 bang. Wait a minute, what do you mean you don't contain? Oh, because I don't want to use effect. I want that to be the material. Duh. There we go. There is no given argument that corresponds to required form of post-process material. Eh? Oh, I just need to put in a constructor, do I? Okay, that's fine. Then yeah, we don't actually need to do anything in there. I can just do the base because yeah, we're not gonna do anything funky. But that's gonna make adding these custom passes like so much more straightforward instead of having to write out all this boilerplate over and over. Yeah, we can just type in one method, which is very nice. Whoops. Delete that. CRT render pass, and this is going to be a type color remap effect. Let's do that. You don't need anything doing, and you are going to do this. You're going to be our post-process material, post-process material, post-process effect, post-process effect, and color texture handle, color texture handle, post-process material. Boom. So if we jump back over into Unity, we should hopefully not have any errors. Oh, we do have errors. No argument given that corresponds to the required profile sampler name. Oh, great. Yeah. So now I just need to make sure I instantiate these properly. So you're going to be scan line filter pass, and on this one let's call it color remap filter pass, and we are setting color target. So now everything should be working as it was before. Good, no errors. I can go onto my render feature and disable the thing. Good, 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 good. And we should also be able to enable and disable it. Now, I messed up. So this is actually working how it should. If I disable the color remap, it's still green. And the reason for that is because when I was writing this originally, I forgot to destroy the instance of our color remap material. So there's still like a lingering material somewhere that I can't quite figure out how to get rid of yet. That's kind of a pain. But I will fix it. And there we go, we can enable and disable our scan line as well. And of course enable and disable the whole profile, which it looks so much worse without it. Really adds some extra goodness. Cool. So what I would like to do is effectively do the same thing but with a noise filter, so that we get some like dynamicness in our thing, because we can see in here at the moment it's all very much static. And let me just disable these texts and bring back some UI example we can see here. Even if I was to like grab, I don't know, let's grab what shall I grab? Modules panel. I want the module pipelines. I'm going to grab this core pipeline nodes, and I think it's going to be like something like this. We can like move this around. Everything works with the screen and it's all looking kind of cool, but there's no like, I want to give it some texture to really like nail home that effect. So we're going to make a new shader in here, shader graph URP, and we're going to make a full screen shader graph. This is going to be our noise filter. Pop this open. And let's figure out what we're going to want to do here. So there's going to be a few pieces to this. Piece number 1, we want a float for our magnitude. And we're going to go in here and set the mode from default to slider, so it can go between 0 and 1. I think probably we can also have a float for like noise speed. And this is going to have a default of, let's say, like 25. And I'm also going to give it a... Oh, I can make it an enum. That's cool. I was gonna say I'll make it a slider as well, but I don't actually want to make it a slider, I don't think. Cool. So here's where I want to ask myself how different types of noise work in Unity, and I think we're gonna be good here because we've got yeah, we can generate this like this. I wonder if we can like color our noise easily. Let's also have a noise resolution, and I will make this one a slider. So that's going to be our scale for the noise. Going to give it a default value of 100, maybe higher than 100. Let's maybe say 500. Yeah, cool. And let's give it a minimum of 250 and a maximum of like 2000. Yeah, cool. And let's make it 750 by default, actually. I've decided. Also, Cut of the Lamb is not the vibe right now. I'm thinking we want something else. It's just like a little bit too energetic for what I'm after right now. There we go. Let's go with Stray. I'll wait for YouTube ads to disappear because I want me some ambience on the back of this as well. But they're just like super long. It's proper annoying. If anybody who watches this back can like name what the adverts are with me talking over the top of them, you get special internet points. Let's say that. Special internet points. Come on, come on, come on. There we go. Nice. That's more like it. Get the volume up for myself a little bit as well, and now we are more in the zone. So I'm actually, just for the time being, we're going to take our noise speed, we're going to multiply it by time, and we are going to use just normal time here, and we're going to pass that into our UV. Oh dear. Wait a minute. That's not what I want to do. That's not what I want to do. I think what I want to do... Oh, I didn't mean to delete the whole thing. There we go. Right, so we've got time. I want to take this and put it through UV... Tiling and offset. And that's going to go into my... I think my offset, and then I can plug this in here. Yeah, there we go. So now we've got TV static, and I think actually we could probably be like really stupid simple with this, and just feed that directly in as an overlay on our texture, multiplying it again. It may not be that simple. I may want to fiddle with it, or probably what I want to do is similar to what I had before. We're going to do a lerp, and we're going to have the value of this be the time, or be t, and we're going to lerp between 0 and 1 based on the value of this. Great. So like the fun thing, if we reverse this, we get the opposite of what the noise is, but you can't really see because it's noise. It's crazy. So now that we've got that, we can use this. Yes, of course. Right. Bang. We want to pull in our screen texture, URP sample buffer. We're going to grab our blitz source and we're going to drop that into our 1. And it's gone black here, but that's normal. Don't worry. So we're going to lerp between nothing and whatever's on the screen based on what our noise texture is. And then we're going to plug that into our basic out. Cool. And then, of course, we're going to move everything nice and in line because we like neat shader graphs here. We're not monsters. Save that asset. And now let's actually integrate it with our effect here. So we've got 3 parameters: magnitude, noise speed, and noise resolution. So let's start off by making our custom post-process step. So we'll go in here. Yeah. Create C#, and this is going to be hello. Create C# script. There we go. Screen noise effect component. So this is going to inherit from volume component and implement I post processing volume. I think that's what it's called. I post process component. There we go. Bang. Let's implement that interface as well. We're going to have is active return active. And we're going to have is tile compatible return false. Oop, deleted my closing curly bracket by accident. Oh, my cat is back. Come on then, actually come inside this time. Okay. I've no idea if he will have actually shown up on camera just then. I'm assuming he probably will have, and you'll almost definitely be able to hear him too. So, let's see where we're at. 40 minutes. Not bad, not bad. I would like to create a public float parameter called noise magnitude. Actually, I don't even need to call it noise magnitude because we know that it's noise. I'm just going to call it magnitude. And we're going to have this be equal to a new float parameter. And actually, it's not just going to be a float parameter. It's going to be a clamped float parameter. New. And here we set the default value, which I'm going to set to 0.75. The minimum value, 0. Maximum value, 1. And if we want it to override the state, by default false, I want it true. We will have a public float parameter, which will be our noise scale. Oh, sorry, our resolution. I'm going to set the default to whatever I had it in here, like 750. And we also have this clamp too. I wonder if I can have a clamped int parameter. I can. Awesome. So default 750, minimum 250, maximum 2000. Again, override the state. And of course, I forgot our public float parameter. This one is not clamped. Float parameter, speed. I guess I'll call it, I will call this noise speed, because speed on its own doesn't feel quite descriptive enough. Maybe static speed. And we'll just set the default to 25, override true. Cool. I'm going to go ahead and copy paste our volume component from one of my other ones. So this just gives us in the post-processing options, when you click add new post-process volume, it will give us custom CRT effects, and this is going to be noise. So now back in Unity on our CRT volume, let's just close down some of the ones that I don't want to be messing with. We can go add override, custom CRT effects, noise. And we've got all of our parameters here with the default values. I'm going to move this up to the top, because actually it doesn't matter necessarily where we do this. We could do it first and then remap everything after. I think I'll probably leave it at that because I'm feeling lazy and I can mess around with it a little bit more afterwards. It's also important to note that this is happening, all of these custom effects, the way we've set it up, like we said before, this is going before post-processing events happen. So it's going to do all of our effects first, and then it's going to run all of the post-processing. It's also going to run our effects in the order that we define them in our render pass. So at the moment, we are explicitly writing out that we want to do the scanline pass and then the color. Oh, well, no, sorry, other way around. We're writing we want to do the color map pass and then the scanline pass. So the order that they are in the post-processing volume isn't actually going to make a difference to the order they're executed. It's purely dependent on the order that we pass them in here, which maybe we'll have a look at fixing that or changing it so that it will do it on the order of the post-processing volume. We might even look at potentially just taking this out completely from the post-processing volume and turning it into some kind of separate profile, or even perhaps just integrating it entirely with the post-processing system, so that we can just, you know, add it as a bunch of extra steps or intercept like the baseline post-processing that Unity has. I don't know, we'll see. Anyway, let's go ahead and start setting some other stuff up. So I'm going to just close down this render pass class because we don't need to look at it anymore. And we're going to make a new class, noise filter render pass. Going to inherit our CRT render pass, and it's going to be of type noise filter. No, what did I call it? Screen noise effect. Bang. Do all of our stuff. Don't need to do anything special in the constructor. And then over here, we are basically going to do the exact same thing that we've been doing already. We're going to, and actually that makes me think I could probably move this blit out into our filter, because we're only doing the one blit. Thing is, this might change, but yeah, I don't right now, it's not going to. So I'm going to change this to config or set up post-process effect like that, and then we can just perform the blit in the top level class. So we don't have to do any blitting in these classes. We can just set up our material with its required parameters. So Post-process material dot set, and we want to set a float, and we're going to set 3 floats actually. It's going to be our magnitude, and the string that we're passing through here is the reference to, or the reference label for that property on the shader. So in shader graph, when you make a property in your shader and give it a name, it by default sets the reference to whatever that name is with no spaces and an underscore. Or yeah, it replaces white spaces with underscores and fronts it with an underscore as well. So I'm actually going to go ahead and remove the underscores from like my noise speed and my noise resolution, because that's the convention that I've been using for everything, is not having underscores. Let's keep consistent. So we're going to set this to R post process effect dot magnitude dot value. Post process material set float noise speed. Post process effect dot speed. Yep, static speed dot value. And post process effect material dot set float, and this is going to be our noise resolution. Post process effect dot resolution dot value. Amazing. G'day boss, how's it going? I'm adding in noise and it's hopefully going to work. It's hopefully going to work, he says. Reason it's currently not working is because we need to go ahead here and actually, you know, put it on our render pass. So we're going to have a private shader. This is going to be our noise shader. And then what we can do nice and easy is in our create, we can go ahead and say, oh, I need to start again. Private material. We also want to have a reference to an instance of that shader as a material. So we're going to say noise material. Banging. Noise material equals core utils dot create engine material noise shader. And then we want to make sure that we clean up that material as well, so we don't end up with a similar issue to what I had before. Noise material, lovely stuff. You're watching the stream while you're in the office. Nice. That's dedication. We like that. And final thing we need is a reference to an instance of our actual pass. So noise filter render pass, noise render pass equals null. Go ahead and say our noise render pass equals a new noise render pass. Oh, equals new. We're going to pass in our noise material and we're going to call it noise. Yeah, screen noise filter pass. And then when we set up our render features, I want to go here and do the configure on my color remap pass as well. Configure input scriptable render pass dot color. Do similar for our noise. Noise render pass dot configure input color. And we're going to go ahead and say our noise render pass dot set color target renderer dot camera color target handle, because we want to pass in the handle, not the thing. ID is a little small. Yeah, sorry. It's because I'm running my fancy new 4K screen. So like usually I would have it about that big on screen because I'm actually a psychopath. But is that better? Let me double check on my phone as well, see how that size looks. I could go a little bit bigger still. There we go. Cool. maybe there. Yeah, sweet. All right. So got all of that set up. Final thing to do is just enqueue this pass. So like I said before, I think the only important thing is that noise happens before here. We want scan lines. Scan lines should happen last. Reason being because the scan lines are what's like effectively simulating the physical pixels on screen. So anything else to do with the actual image of what, you know, what an effective GPU would be trying to render to the screen, that should all happen before the scan lines and before any of the warping, bloom, all of that stuff should happen last, because that's, you know, simulating the screen and the camera rather than doing any of the other stuff that I just said. So the noise could go on either side of this. I'm going to put it below for the time being. And what we can actually do, we can compare the two, because maybe it makes a difference. I don't think it should, because we're not like doing any multiplication. We're just lerping between, you know, effectively black and whatever the original color of the texture was based on how black or white the noise is. So, you know, oh dear. So we need to now go ahead into our settings, render a 2D, and we're going to go and plonk our shader into this noise shader, noise filter. Hey, would you look at that? So that looks really weird. Let's can I enable constant material updating? Pretty please. I think always refresh. That's just going to do it in the scene, not in the game mode. So actually I'm just going to hit play so that we can see this. And of course, that is way too small, way too big even. So I'm probably going to drop the magnitude a little bit. Oh, but that also seems to not be having any impact at all. That's curious. I wonder why our noise is just getting applied constantly instead of looking at the... That's very interesting. Is this going to be where I find out that I've got like a similar issue to what I'm running into with the color remap, and for some reason it just doesn't happen with the scan line? Maybe it's because the scan line doesn't have any defaults. Oh, but the scan line does have defaults, and I can disable the scan lines fine. So some weird's going on. I also don't particularly like how this noise looks completely on screen. It's like, oh, that's kind of cool. Yeah, weird. So changing the thing in here is like making a massive difference. Or yeah, it's changing rather than actually using our post-processing effect as the driver. Very curious, very curious. Yeah, I wonder why that is. So we're making an instance of our material, passing that instance of our material through to our new render pass. We are cleaning up the material afterwards, setting all of our color stuff. We enqueue it here. Gonna move it ahead because I'm feeling fancy. I wonder if for some reason it's not finding the screen noise effect component as the instance, because this is odd to say the least. I'm going to bump the resolution up to 2000 in here, and I'm also going to bump the speed up to like 50, and I'm going to hit save asset. Oh, and again, that hasn't made a difference in here. Oh, it is making a difference. It's just like it needs to be way big. Like way big. So maybe for our noise resolution, maybe we need to actually, can we get the UV out of this? I think there's a if I go in my tiling and offset, I can probably set the UV to be or the tiling to be here we go. Right. I want to get the screen width and height, and I think I can combine these like so, and then plonk this out into my tiling for the noise. Yes, there we go. There we go. That's better. That's probably not visible on stream. But it's now actually rendering properly. So I can, let's default this to like 5 and change this minimum to 0 and 1,000. 100, 0 and 25, like that. Save asset. And I need to make sure that I update this, these things in here, to be between 0 and 25. 5, 0, 25. Oh, of course, we don't want a resolution of 0. Don't want a resolution of 0. It should be minimum 1. Nice. So now we've actually got some noise in here, but now it just looks like it's scrolling. So we definitely need it to like move a whole bunch faster. Either that, or we can just maybe plug this into the UV instead of the offset. Oh, but yeah, then we get we get fully strobed. Let's not do that. Oh wait, I think I can just plug in random, can't I? I still need to multiply this by time. So right, we're gonna do, because we want it to change over time. So let's get our time in here, and then we're going to multiply that whole value by our random number, which let's make it between like 1 or 1 and 100. And then we're going to use the output of that as our offset. No. I don't want it to just scroll. I want it to jump around randomly as the thing. So now I've got to actually flex my brain powers. Hey, Turbo Rocket. I am attempting to make a old computer screen looking post-processing feature set using URP and shader graph because I don't know how to write HLSL. And it feels more straightforward, or well, I say it feels more straightforward. It's more straightforward for me at this moment in time to use shader graph. So we've already added scan lines and color remapping, so I can go ahead in here and change the color that it's gonna put out on screen. So like I say, next thing that I want to add is noise. And I'm just trying to set it up so that it like randomly jumps the noise around instead of just kind of scrolling it smoothly, because we don't want smooth scrolling, we just want random offset. So I'm wondering if I can just get like a random number. Or maybe maybe I'd be really stupid and I use the output of this noise. So if I get some like simple noise and have the tiling and offset of that. Stop. Tiling and offset. If I take this, have the offset of that be set by this, plug that into my simple noise. Oh, I plugged it into the scale by accident. I don't want to plug it into scale. I want to plug it into that. Wait. Brain cells rubbing together. I think I've just put things in the wrong place. So, as normal, offset like so. I just want to not have the tiling there, but instead want to have it like after the fact, I believe. Can I not shift click nodes in here? I guess not. I'm probably going to need to up that noise value again. Right, brain. Yeah, I can't plug you into the texture port of a sample texture 2D. What I would like to do is, exactly like I said, take the UV, or effectively take this and multiply it by, maybe I could just do that. That's not what I want to do though. That's not what I want to do. So now this noise texture is like stupid big. Let's just not make this clamped. Let's make it normal. Get rid of these. I'm going to default it to 5,000 and we're going to see how this looks. Right, resolution. Let's just absolutely crank it. Right, something must be not right here, because let me turn off a bunch of the other stuff. That to me doesn't look like it's getting any smaller. So at this point, it's then a question of, you know, do I continue trying to generate this noise, or do I just use a noise texture and offset the UV randomly that way? Which, you know, I'm not gonna lie, I'm kind of tempted to do. If I saturate this, no, I don't want to saturate it. I want to compare. So if it's 1, output true, and let's look based on that. So we get pure white and pure black rather than, you know, shades of grey in the middle. There we go, that's better. Whoopsie daisy. You, my friend, are B and you are T. This is it's not it's not going to plan. This is not going to plan. Oh, brain shaders. All right, I think probably we want to go back to the drawing board on this. I mean, I could push this through another lerp. Because I don't want to go 0 to 1. I want to go like 0.25 or 0.25. So then we're going to end up with like a little bit of the thing coming through. And then actually this is where our magnitude plugs in. So let's have a default of there we go. Have it go through a 1 minus. So then when it's 0, we have nothing. And as it increases, yeah, cool. Cool. So let's give it a default of like 0.75. So then it's just getting the scaling right and the movement right on this thing. So I think I was probably doing the right thing before, where I was factoring in the screen width and height, and using that as the UV coordinates. You know, perhaps I can just increase the tiling. Can I use this as the tiling instead of the UV coordinates? Oh my god, that's it, isn't it? That's going to be it. Yep, there we go. So then rather than multiplying the scale, I think I can multiply my screen resolution. I need that to be a float then as well. So float clamped float parameter, and we're gonna go default 0.01, and let's go between 0.1, 0.01 and 1, I guess. See what we can mess around with here. Yeah, there we go. Oh, look at that. That's it's like snow. Not quite what I want. Give it a magnitude of 0.5. I'm gonna up the resolution a fair bit. That's kind of doing the business. Yeah, got a bit of noise going on there. I don't know how well that shows up on stream like, but hopefully you can kind of see we have indeed got some noise going on there. So that's cool. That's cool. So the other thing then that I want to do is some like positional offset, which is going to be a little bit more funky, I think, because obviously for a full screen texture we don't have you don't have vertex offset. You've just got to manipulate the UVs. And we can tell from you know, having just done this exercise, UVs are not my specialty. Also, what is this all about? When I disable the render feature, it just gives me some default gubbins. It's the way the noise is generated. I want to change the seed or something of the noise instead of the you know, instead of the what's it. What's a noise sine wave? Oh, that gives me a random value. Yes, let's go. So I could plug this in here. Flashing light warning. Bit late, but let's put that in there. Let me just close that real quick. And let's make this go between 0 and 1. And then maybe we'll use this as the offset. Let's plug this into a noise. I don't know. Let's have a look at gradient noise. That's exactly what we were just using. So we don't want gradient noise. Let's have a look at... Wait, no, we weren't just using gradient noise. We were using simple noise. Maybe we do use gradient noise. Oh, yes, there we go. There we go. That's more like it. That's more like it. That means I could probably decrease the static speed as well. Oh, look at that. And we even kind of get like this faux flickering sort of vibe going on. Yeah, that's brilliant. That's brilliant. Yeah, I can make it super subtle. Oh, fantastic. Fantastic, fantastic, fantastic. So then for the static speed, No, that is fine. Shield your eyes, flashing lights. So do I actually want this noise to be like higher? Because that don't make no sense. I would guess I'd want it to be a decimal. But that then feels like it changes way too quick. I don't know. I'm happy enough with it at the moment that I can live with that. Because that looks so cool up close. Looks so cool. And yeah, we can get all like different colors and stuff going on. Let's go maybe 0.95. Resolution was cool as is. I think maybe I'll bring the magnitude down just a little. And I am going to up the speed again to like 200. Maybe 0.45, yeah, so it's not like super subtle. It's still there, but it's not like super intense either. Still works with all our different colors. Yeah, brilliant. And also looks good. Oof, yeah, look at that. That's nice. That is nice. I can see like where it's rendering the screen small on my like phone and stuff. You can really see the effect of the scan lines. And I mean the cool thing as well is that I can change this scanline texture. So at the moment I'm using just like a color grid. Use a different type of color grid, vertical and horizontal scan lines. And it's like it's really quite interesting to I'm just thinking about the scan lines thing. What I probably want to do, rather than what I'm doing at the moment, where I'm splitting it, combining it, and splitting it, multiplying it, combining it. I probably want to split and then do a comparison to see how close the colors are or something like that. Or like multiply by the difference. I'm not sure what the maths for that is. My brain is not having it. My brain is not having it. Oh, Felix, you're here. Quick, tell me, what type of scan lines do you like the most? Do you like the... Because I mean, that one looks pretty cool. That's the most typically sci-fi, I think. And then the more kind of authentic old style screen is probably this one. It has a massive impact on the color. For sure. That one's horrible. Vertical scan lines I'm not a fan of. That one's kind of okay, but I'm still not a huge fan. So for me, it's between this one and this one as the baselines. And you get much more vibrant color going through just plain white lines. All of them. All of them. Fantastic. That's so helpful. Thank you so much. can we do? Look, we can reduce the amount of lines there are as well. So like, it really does. It really does. It does a lot. I think I'll stick with this one for now, and I'll keep it like high at 250. Because there's something about it that I just grabs me. I still don't know what the deal is with these textures not doing the thing they're supposed to do when I enable or disable them. The scan line effect works perfectly. If I turn that off, it turns it off. But for some reason, the other ones are just like, I'm gonna hang around. I feel like lingering. And it's weird because I'm not doing anything different between each of the different things. So very peculiar. I said I was going to stick with this one. I've changed my mind. I'm going with this one, and I'm going to set the scan line to like 225. And maybe there's something that I do with like pixelating. Simulating pixels. I might have to do some research into that. I might have to do some research. I'm changing a bunch of stuff like it's gonna be set in stone, but it just isn't. That's a little bit better, I think. Not quite so intense. Yeah, that'll do me, that'll do me. Maybe just a little bit extra on the chromatic aberration. Not that much extra. You know what, actually no, it doesn't need to be any extra. Maybe just like up to 0.85. So there's a little bit of fuzzy on the edges. It's kind of cool. Yeah. Yeah, that works for me. But I do... I need to stop. I need to stop. Okay, right. So, yeah, 4:30. So I probably don't want to go for too much longer. I would quite like to add a the noise filter that I was talking about, or like the, you know, the static kind of shimmy filter. So maybe let's have a go at that. Let's just create a new shader. No, URP. Shader graph, URP. Full screen shader. And this is going to be our screen static shader. Cannot create required material because it's null. What do you mean? I'm not trying to make a material right now. I also feel like I want the noise to be a bit more impactful. Yeah, there we go. There we go. Nice and chunky. 0.775. And that gives us some actual proper, like, yes, much more like it. And of course, you know, the benefit of doing things in this kind of way is that all of these can just be linked up to like settings. So if there's a player who doesn't want the noise or doesn't want the bloom or anything like that, they can just go in and change the values. Jeez, excuse me. Change the values in the game settings. So very cool. I'm gonna grab our sample buffer again using the blitz source. And we then want to, so we probably want a texture that's going to be our static texture. Gonna go ahead again and, like I say, set our default, our reference to be in line with what I want. And then what I kind of want to do is I want to figure out how to offset the UV to the right based on how much white there is in this texture. So we'll have a float for the magnitude. Let's plonk a default in here as well. For some, yeah. And then these sections of full white we can basically have offset fully, and sections of black we won't offset at all. So how is this gonna work? Can I plug you into a sample texture 2D? I could plug you into the UV, not into the texture though. Of course, because you're just colors. There is no UV information. So what do I want to do with that? How do I convert that? It's these UVs that I need to change, or I need to do like a tiling and offset in the UV here. I think Google. Unity, or yeah, shader graph offset UV based on color. That's not what I'm looking for. Or maybe it could be something that I'm looking for. So I have a normal UV. We'll imagine this is the UV of the screen. I mean, this is the problem that I've got though. I basically want to construct a texture. Based on Is that what I want to do? Is that actually what I want to do? Shader graph, full screen, warp, shader. Reddit. YouTube video.
Hello everyone, welcome back to the channel. Today we will create simple underwater effect using a full screen shader. By the end of the video, you will...
Here we go, distorting the screen.
Using these UVs. And for that, let's create a UV node.
Wait.
Let's fix it by creating a scene color node. Scene color node will give us color from our camera's color buffer.
So that's effectively the same as our blit texture. We're just doing it different because we're going to use a render pass.
Is rendering based on this UV. Simply take scene color node's output and feed it into the base color block. And we can see that our scene view has become normal. Now we can distort that using these UVs. And for that, let's create a UV node.
Or maybe that is what we want to do. Maybe that is exactly what we want to do. Is go in here, rather than using the sample buffer, let's use scene color. I think that's exactly what we want to do. And then we can offset the UV. If I plug that into there and then output this into there and then save the asset. Let's go ahead and make our features, shall we? So I'm going to start off with private shader, static distort shader. Same thing again, let's make a material, private material, static distort material. I'm actually going to go ahead and put the dispose in here straight away, because then on our settings. Ah, Lord. Need more sleep. Screen static. And then let's go ahead and just make a pass. Public class static distortion render pass CRT render pass. We don't have a type for this yet, so let's create, let's do the full process. Create C# screen static, or yeah, let's just call it static distortion, static distortion effect component. Volume component. I post process component. And I'm not going to worry about parameters for it right now. We're just going to go ahead in here. That's going to be our type, static distort effect component. And we're just going to do nothing for the time being. That's fine. Good. Do that. We are going to make a static pass, new static material, static distortion filter pass. And then when we set up our render passes, similar thing. In fact, I don't think I need to do that. Static render pass, set color target, renderer, dot camera, color target, handle. And then we'll enqueue this last and see what this does. Yeesh. It does crazy things. What is it that the guy was doing? He said we need to add, don't we?
To lerp node.
So you're going to be my lerp A. And we're going to lerp based on this. That's it's not quite right, and of course that needs to go in there. Oh wait, no, I do need to use the blit. I do need to use the blit texture. Ah! Does the blit texture have an input for UV? It does. Let's go. This is what we like to see. There we go. Oh, let's go. Okay, cool. So that's kind of doing a thing. I think probably what we want to do is multiply, or maybe we just take the R value out. Yo, look at that. So why, I think. I can make that -1. Oh, look at that. Look at that. That's fantastic. Sheesh. Can I get a, can I I mean, that's something else. Right, okay, so things I want to do then. Magnitude is going to be this Y value. So I would like to effectively, if magnitude is at 1, I want this to be -1. If magnitude is at 0, I want it to be 0. So we're going to multiply by -1 plug that into a combine blue, no, combine green, and then whack out our 4-channel so that we've effectively got the vector. So we should be able to see here if our magnitude is at 0. Oh no, what am I talking about? That needs to be cut off, not magnitude. So magnitude is actually going to be this. And we're going to do a multiply again. Multiply this. That's going in here. So if my magnitude is 0, normal UVs. If my magnitude is 1, yeah, cool. That's good. You're going to be a slider between 0 and 1. Default. Let's give it a default of 0.35 maybe. If I save that now, we also do not have this doing its thing because I would like the I need to set the cutoff, yes. So add a new one. Or maybe I just have, maybe I just don't. I just leave the cutoff as, you know, -1. Huh? Why is it now not doing what? Why is it not doing the thing anymore? It was working. What's going on? Let me plug that straight back into here again. Okay, plugged straight in, it's fine. Through the multiply, it's not, which makes me think my magnitude is probably just 0. So let's go ahead and actually have these values pass through, shall we? Post-process material.set float magnitude. Post-process effect dot magnitude dot value. Oh my gosh, can't type. We'll go ahead and actually give ourselves a magnitude. So public clamped float parameter magnitude equals new, default of 0.75, minimum of 0, maximum of 1, override state true. Cool, that's better. So now in my screen noise, I want to add a screen distortion. Nice. So it's not quite doing what I wanted to do. But it ain't far off. Maybe it's because I do actually want to be using X. So that seems to has some kind of effect. This is where a lack of understanding of UVs comes in. Okay, I know I don't want it to be on Z. Maybe I do just want it to be yellow, so it's like full. That takes it down and left. If I'm just Y, that takes it down and right. Okay, great. If I'm just X, that takes it up and left, doesn't it? Yeah. So maybe I want to be like that. No, that's not it. Also, let's actually just have our main screen enabled. Wait. Here's what we do. We are going to have a tiling and offset. And this is going to be the UV. Tiling is going to be 1, 1. I want the offset on X to be like 0.75. That's going to be what we look between. Oh, there we go. There we go. So we can have like minimal offset, and we could actually probably have this be baked in with some flickering. Yeah, there we go, there we go. I am having way too much fun with this. It's just way too easy. So yeah, we can probably have like some flickering on this. So rather than using a hard-coded value, let's do R. Now, if I do random range between 0 and 1 and plug this into there, I suppose I have to change the seed, don't I? There we go. Right, cool. So I can have a time node come in here as our seed. Save that asset. And now if I up the magnitude, we do indeed have flickering. It's very, very speedy, probably more speedy than we want. And also, like, if it's at this level, it's just way crazy. So maybe this should be like 0.1. Still way crazy. Although it shouldn't be way crazy, should it? Because we're not offsetting by that much. And I'm not using magnitude anywhere else. Just to be certain. No, I'm not. I think this is cool though. I'm making solid progress here. Which is awesome. It's just like, why is having the magnitude all the way up making such a big difference? I think the answer to that question, no, because the default there is still 1. I wonder if I have -1 as an option and then +1. Yeah, that does make it flicker both ways. So we'd rather have -0.01 and 0.01. There we go, that's much more feasible. Or much more like, you know, good. Probably what we want to do then is take our time and multiply it by, you know, some smaller value. So that it's not quite so ridiculously speedy. Probably go even smaller than that. Oh no, because it's still changing. It's still changing. I only want to change it like... Can I have like a tick? Or a clock? I don't know, I'll figure it out, but... Compared to where we started, you know, this is really cool progress. This looks like a proper old screen being rendered. So I am coming up on 2 hours. I think I'm going to call the stream there. So I want to say, you know, thank you very much to everyone who took the time to come watch. I know it's kind of a weird time. It's middle of the day. But again, it's kind of because my time is a bit freed, so I can stream now instead of in the evening when I want to be spending time with my girlfriend instead of sat at my computer. So again, thank you very much everybody for watching. If you enjoyed, leave a like, make sure to join the Discord server linked in the description, and yeah, I'll be back with another one real soon.